So in this video, we're going to determine hybridization, and we're going to look at a central atom. Let's just focus on the central atom for us. A couple things to remember: 4 directions, that includes sp3. 3 directions includes sp2. 2 directions will be sp. One thing about it, in this case, when I talk about hybridization, when I'm looking at directions, I do include the lone electron, lone pairs, or the non-bond electrons pair. So I consider that a direction. And I'll show you that when I look at ammonia and H3. So a few things about this one. Let's look at this. Again, we're looking at carbon. We're going to focus on carbon. This is carbon tetrachloride. There's 1, 2, 3, 4. 4 bonding directions, sp3. Simple as that. This is look at ammonia. Now this one is where we got to include the lone pair of electrons. So I call this one pair, 2, 3, 4. So I do include that non-bond pair of electrons or that lone pair of electrons on that central atom. 1, 2, 3, 4, sp3. To kind of finish up the hybridization, let's look at CS2. Again, we're looking to focus on carbon. So there's 2 directions here. 1, 2. 2 directions, sp hybridized. So that carbon is sp hybridized. Let's look at ozone. Again, let's just focus on that central atom. Lone pair of electron counts. That's 1 direction. That's 2. That's 3 directions. So this is sp2 hybridized. So again, 4, 3, and 2. It includes those non-bond pair of electrons on that atom. To kind of finish this up, these I just wanted us to determine the number of sigma and pi bonds in there, just to kind of review. This is oxygen, so oxygen is diatomic, so it's O2, oxygen air is O2. This is its Lewis structure. So if I look at this, it's a double bond, which means that there's 1 sigma plus, and there's a pi there, plus 1 pi. So a double bond is 1 sigma plus 1 pi. Again, it's the overlap of the orbitals. Internuclear for sigma, above and below the internuclear for the pi. Let's look at ammonia. Now, not ammonia, nitrogen. Now, nitrogen gas, that's a triple bond, so it's stronger than oxygen gas. So nitrogen gas is less reactive than oxygen gas. And that triple bond, this is a sigma, that's a pi, and that's a pi. So basically, 1 sigma plus 2 pi bonds. Again, that's going to be stronger now than the double bond on oxygen. So triple bonds are harder to break. So nitrogen gas is less reactive than oxygen gas. Last one is hydrogen gas. Hydrogen gas is reactive, and the reason is it's just 1 sigma bond. So again, be able to look at single bonds, double bonds, triple bonds, determine the number of sigma and pi orbitals in there.